I want us to look at this chart here on the left. So the right-hand side may look similar to what we were working with in the compound formula. We have 1, think of 100% of the original, plus 1 over n to the power of n. So as that n gets larger, 1, 5, 10, 100, notice that we're getting closer and closer to a particular value, 2.71828. So from this table of values on the left, it appears that as n approaches infinity, this expression, 1 plus 1 over n to the n, is approaching 2.71828. This number is actually defined. It's the number E. Some people call it the natural number, but it's also called Euler's constant. I know it looks like Euler, but it's pronounced Euler. Euler's constant. And the number E is an irrational number like pi, 3.14, and it goes on forever. So we cannot write it in an exact form, so we still use it as E. Now, when do we use E? When we have a continuous growth or decay. And that's represented by the formula where we have A times E to the RT, where A again is the initial amount, and that initial amount is typically greater than 0. R is the continuous growth rate if R is a positive number, or the continuous decay rate if R is a negative number, okay? So when we talk about continuous growth or decay, think of it in terms of like a compost, or if you're trying to carbon date material that you found in an archaeological dig, it is constantly decomposing. Unlike compound interest, you only get interest every month, or every 3 months, or every year. But some things just continually grow, like plants, right? They're continually growing, your hair, your fingernails. So whenever we're dealing with a continuous growth or decay, we generally use this formula. We can convert it from a continuous to an annual, but it depends on how they're giving us the information as to which formula we're using. And again, T is the time elapsed. Now for business applications or money, when we have continuously compounded interest, they just use P instead of A. It's the exact same thing. So you may have heard of the PERT formula. P is still your principal or initial amount. R is the interest rate, generally per year. And T is the time or period of investment, how long you're leaving the money in the bank. So radon 220, that's the name, decays at a continuous rate. So we got to pay attention to that word. Decays at a continuous rate of 17.3% per day. How much will 150 milligrams of radon 222 decay to in 7 days? So it's a continuous rate, so we know we're dealing with E. Because it decays, okay? Remember, if it decays, that means we're going to write our rate as a negative. So our R is going to be a negative 0.173. Then it's asking how much will 150 milligrams, so this is our starting amount, decay to in 7 days. That's our T. Well, capital A equals little a times e to the RT. So we're trying to find that ending amount. If we started with 150 e to the, and it decays at a rate of negative 0.173 for 7 days. Be sure your units in your T is the same as your unit of your rates. So if that's how much it's decreasing per day, be sure that they're giving you days. If they're giving you weeks, you need to change the time to days. Be sure those units are the same. So we can put all of this into our calculator at once. So we can put in 150. The E is the button here right above your division symbol, or up here above the ln, which is our natural log. This E to that exponent, we can use that guy since we are putting in an exponent. So second function ln, and look at there. And then we are multiplying in that exponent. So we want a negative. Notice I used this negative here, not the minus sign. In graphing calculators, they recognize them as two different things. So if you have a negative number by itself, or you're starting with a negative number, use this symbol. Otherwise, it will tell you there's an error. So a negative 0.173 times 7, close parenthesis, and that gives us approximately 44.6849 milligrams, depending on how far you're asked to round it. So our amount is approximately 44.685 milligrams. All right, so that is it for the first section in chapter 4, which deals with exponentials and logarithms. See you again soon. Bye.